This video, I want to go over the remainder theorem, factor theorem, and rational root / zero theorem. Now, the first one is a remainder theorem, and it says that for any polynomial function capital P of x, and for any real numbers lowercase a, if capital P of x is divided by the binomial expression of x minus a, then the remainder can be found by evaluating your given polynomial function at the value a, or the x value a, I should say. And your polynomial function capital P of x can be written in the form of x minus a multiplied capital Q of x plus capital P of a, where capital Q of x is the quotient of this division. Now the next one is the factor theorem. The factor theorem says for any polynomial function capital P of x and any real number lowercase a, the binomial expression x minus a is a factor of your polynomial function capital P of x if and only if. That's what IFF stands for, if and only if. The remainder, capital P of a, is equal to 0. There are two ways to write your biconditional statement. You can go from the left to the right by saying that if the binomial expression x minus a is a factor of the polynomial function capital P of x, then the remainder, capital P of a, is equal to 0. So that's how you go from here to here. So this right here is the if part, or the hypothesis, I should say. And this is the then part, or the conclusion. And at the same time, you can also go from right to left, and that is also true as in going from left to right. And going from right to left, you have, if the remainder capital P of a is equal to 0, that's the if part, hypothesis, then the binomial expression x minus a is a factor of the polynomial function capital P of x. So this now is the then part of the conclusion. What the factor theorem is saying overall is that if you do a division of your polynomial function by a binomial expression, either by long division, syntactic division, or by using the remainder theorem, and your remainder turns out to be 0, then that means that your given binomial expression, when you set it equal to 0 and you solve for x, will be the factor of your given polynomial function. So that is the idea of going from right to left. And when you have to factor out completely your given polynomial function, most of the time you will use the right to left. Now the last one is the rational root / zero theorem. And this theorem basically says that for any given polynomial function capital P of x, and it is equals to a subscript n multiply x with the highest exponential power plus a subscript n minus 1 multiply the variable x with the second highest exponential power, and it's going to keep decreasing like this all the way down to until your x variable is raised to the 0, which is just positive 1, so that's why a sub 0 is staying here by itself. And of course with x subscript 1 times x to the first here, where a0, a1, all the way to an minus 1 and an are the elements of the set of integers. So that is another way of saying that a0, a1, an minus 1, and an are all integers. And all of these integers are not equal to 0. Then for your polynomial function, you can actually list out all of the possible rational roots of your given polynomial function by taking all of the plus and minus factors of the constant a sub 0, and you divide that by plus or minus factors of the leading coefficients. So for example, if your constant is, let's just say 6, right? Then all of the factors of 6 is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. You're going to list out all of that on here, and you divide it by all of the factors of the leading coefficient a sub n. So for example, if a sub n is, let's just say 8, right? Then all of the factors of positive 8 is going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So that way you would have down here plus or minus 1, comma, plus or minus 2, comma, plus or minus 4, and comma, plus or minus 8. Okay, and the same thing for the numerator. So yeah, that is how you use the rational root theorem.